Welcome to the online ACR training videos. This video will teach you how to write AcroPLC programs. Let's get started. ACR's AcroPLC programs are programmed using standard ladder logic commands compiled to machine code on download. These programs are available in all ACR controllers except the Aries controller. Up to 8 PLC programs can be run at one time. Programming can be done in ladder logic or text. Before getting into programming, let's cover the program and PLC timing. ACR controllers can have 16 AcroBasic programs and 8 AcroPLC programs running simultaneously. Progs 0 through 7 are the motion programs using AcroBasic. Each program is assigned its own 1 millisecond time slice. If no memory is allocated to the program in the configuration wizard, the program isn't downloaded and no time is allocated. These programs are for the masters or coordinate systems and is similar to a task in the legacy 6K series controllers and allows for axes to do interpolated motion or run completely separate from other axes. Progs 8 through 15 are non-motion programs and share a 1 millisecond time slice. These are great for running in the background, continuously reading inputs and setting outputs, or updating parameters and global variables. Caution! If you inhibit one non-motion program with the inh inhibit command, you'll inhibit all the non-motion programs. For the AcroPLC programs, one PLC is run every servo period, plus one is reserved for I/O update. Another period is reserved if any timers or counters are used. Let's take a look at an example. This example gives a brief description and shows the timing execution in the ACR multitasking environment. This example has 3 programs and 2 AcroPLCs active. Active programs are scanned in sequence with each program having a fixed 1 millisecond scan time. If a command is not completed during the program scan in which it is initiated, it will be suspended until the next scan of that program. Moves that are started in a program are buffered and then controlled by the servo interrupt. PLC programs are linked into the PLC scanner. This is a list of events that are to be executed at the servo interrupt rate period. The default is 500 microseconds. During each servo interrupt, a single event from this list is executed. This event is executed in its entirety, and the next event is executed during the next interrupt. This process is repeated after the last item in the list. In addition to PLC programs, the scanner event list also contains an input-output clock scan and a timer counter latch scan. When a PLC program is run, the controller first compiles the PLC program source and then links the result into the PLC scanner. Compilation takes the PLC program source and generates high-speed machine code specific to the controller's processor. This step requires a certain amount of memory to store the generated code. An error will be generated if there is not enough free memory available to compile the PLC program. Memory is assigned to the PLC program in the memory section of the configuration wizard, similar to the AcroBasic programs. As an example, 2 PLC programs running at the default 500 microsecond servo rate will be serviced every 2 milliseconds. One interrupt for the input-output clock scan, one interrupt for the timer counter latch scan, and one interrupt for each of the PLC program scans. All 8 PLC programs would be scanned every 5 milliseconds. Here we have one PLC program with no timer counter latches. How fast would the I/O update? If we were reading in an input to turn on an output, if the timing was just after the I/O clock update, first, program 0 would run in the foreground, so that's one period. 2, the PLC 0 would run a cycle, but the I/O hasn't updated yet. 3, then the I/O is updated. 4, the PLC then runs with the updated I/O. And then 5, the I/O is updated with the output turned on. That's 5 servo periods, so worst case it would be 2.5 milliseconds. If the scanner started running when the input also changed, it would update the input, run the PLC, and then update the output, so 1.5 milliseconds. That was a fairly simple example. Here's our timing chart for the example with 3 programs and 2 AcroPLCs. The PLC scanner has the I/O clock update, then the timer counter latch update, and the 2 AcroPLCs all being done in the background. In the foreground, the programs 0, 1, and 8 all get their 1 millisecond time slice. If we were to try to read an input and set an output in PLC 0, if the input updated just after the I/O scan in the very first line, then it'd first run prog 0 in the foreground, 2, run the timer counter update, 3, run the PLC 0 update, 4, PLC 1, 5, update the I/O with reading the input, 6, update the timer counter latch, 7, run the PLC 0 with setting the output based on that new input, 8, update PLC 1, and then 9, finally, the I/O update with setting the output. For the programs, if we look at program 1 and the input turned on just after the first line where the I/O clock update, first prog 0 in the foreground would be run, then the timer counter latch, PLC 0, PLC 1, and then the I/O update with scanning the input, then the timer counter, PLC 0, PLC 1 again. The program 1 runs with the updated input, then the timer counter latch, PLC 0, PLC 1, and then finally the I/O physical update is set. These are worst case scenarios, but as you can see from these examples, the number of AcroPLC programs and AcroBasic programs will affect I/O update times. The input-output clock update event is always in the PLC scanner list even if a P-off command has been issued. As the name implies, this event updates the opto-isolated digital I/O, the global system clock P6916, and the clock tick flags bits 80 through 83. The P-off command resets the PLC scanner list to contain only the input-output clock update event. Currently running PLC programs are put in an idle state and will be put back into the PLC scanner list when a P-on command is executed. Note that running a PLC program also executes an implied P-on command, activating the timer counter latch update event and any pending PLC programs that may have been set to an idle state with a P-off command. ACR controllers can accommodate up to 8 PLC programs simultaneously. These use a limited instruction set that's compiled into machine code for high-speed execution. No motion commands or parameter math operations or comparisons. You can write to bits so you can set the axis to jog forward or reverse. We'll program that here shortly. The ACR9000, 8020, and 1505 have a maximum of 200 command lines of the machine code. Note that this isn't rungs. I'll show you this next. All other ACRs are limited to 100 command lines. Also, the AcroPLCs can only use a maximum bit number of 8191. Because the bit limit of the AcroPLC is 8191, if you want to use the Parker I/O, which is the CANopen expansion, set P32771 equal to 1. This will change the default starting bit 11520 to bit 256, which is the expansion I/O flags, which is parameter 4104 shown here. Let's start programming. Let's write this simple AcroPLC program that will turn on an output if 2 inputs are on. For an EPL demo, you can use bits 3328 and 3329, which are the first 2 input push buttons. Bit 3840 is the first output. After downloading the AcroPLC program, type Run at the PLC 0 prompt to start the program. Let's take a look at this in ACR-View. Okay, here we are in ACR-View. My controller's EPL network is operational and my drives are enabled. First, let's go into the status panels and to the bit status to confirm our push buttons are working. I'm going to be using inputs 24 and 25 since I have a 9030 using the onboard inputs. I can see 24 and 25 are changing state on the EPL demos. If you go into EPL flags, into the digital inputs, you'll be able to see the inputs change state as you push the buttons. And then if you want to see the outputs, those are 38, 40, 41, 42, and 43. We can leave this open in the background. If the inputs aren't changing, check your wiring. Let's go into the PLC Editor, go into PLC 0. I'm going to expand this. Let's go into View, PLC toolbar. So first we're going to add a contact. If you click on the question marks, go ahead and under the bit status, go into EPL flags, digital inputs, and select 3328. And then select another contact. You'll have to do this again. Our second contact will be 3329, and then on the toolbar, if you insert the coil, go into the EPL flags, and now the EPL digital outputs. Our first axis on the EPL demo, all of our I/O is wired into the first Aries EPL drive. So that's why it's EPL D0. Go ahead and press OK. Save and download the project. And you'll notice that note only memory allocated programs have been downloaded. And if we look at the message box on the bottom, it says memory is not allocated for PLC 0. Did that on purpose just to remind you in the configuration wizard under the memory section. You do have to allocate memory for the PLC programs. We're going to be adding more rungs to this, so let's go ahead and set this to 1000 bytes. Finish and download. Go ahead and download the PLCs. Okay, press OK. Okay, so I've switched my program over to my 9030 controller using my onboard inputs. I've actually made a comment here: if inputs 24 and 25 are on, set 32, I could put whatever I wanted in there as text. So if those were specific sensors and the output was controlling a valve, whatever the name of that valve is, it'd make it easier to read the code later on. I go into the terminal emulator and type run. We'll run the program. And if I hold the first two inputs, you can see the output turns on. If I want to see that in the terminal window, if this valve was somewhere on the other side of the machine, you could type question, which is print bit 3840. In my situation, it's bit 32 for the onboard output. I hold the sensors in. You can see it reports as -1, which means the output is on. Or we can also take a look at the bit status under the EPL flags for the EPL demo. Let's expand this program and turn on the second output if either inputs 2 or 3 turn on 5 times. We can do this by adding a counter. Add a rung from the toolbar. Add a contact. For an EPL demo, use 3330. I'm going to be using input number 26. And to add a parallel contact, select the first contact and then select the parallel contact from the toolbar. Your parallel contact would be 3331. Then add a counter function block. There are 8 counters available, and let's start by using the first, counter 0. So select the name, press OK. LD is a reset, so if we give this an input, this will reset our counter, helpful in error recovery. Let's set this to 3332. I'll be using input 28. For the preload value, we want 5 times if either input turns on 5 times. And we want to turn on an output, which your EPL demo would be 3841. Go ahead and add a coil. I'll be using output bit 33. On yours, you can use the second output, which will be bit 3841. I want to go ahead and add a contact. When 28 turns on, I want 33 to actually be cleared and turned off as well too. So I can right click, insert a contact. After with 28 and negate that, so if that contact ever turns on, the 33 will turn off. Save and download. Run. The output turns on. If I turn on my 5th input, the output turns off. If we want to see the current value of the counter under the numeric status, go into the PLC parameters, go into the count parameters, and go into the actual counter count, which is parameter 6663 for parameter 0. If it's still running, you can see the output turns on, and if we hit the reset, which is the 5th button, it gets reset at any time. What if we want to wait 5 seconds before turning on that output? We can add a timer. We go into here, right click, insert function after, select a timer. There's 8 different timers. These are set in milliseconds, so if we wanted to wait 5 seconds, it would be 5,000 milliseconds. Press OK. Go ahead and save and download. Run. So if you go ahead and push your buttons 5 times, and wait 5 seconds, you'll see that the output turns on, and then if you push input number 5, it will turn off. You can run that again. If you want to see the elapsed time of the counter, go into the numeric status. Instead of the CNT, go into the timer parameters and go into the count. If you push it 5 times, you can see the counter starts to count down. Once it reaches 0, then the output will actually turn on. Okay, this is nice and everything, but we've got a motion controller here, so how do we command motion? We can set the jog forward bit 796 or the jog reverse bit 797 based on our push buttons. We'd want to check other conditions, so let's make sure interpolated motion isn't being commanded, which is bit 516, or gear motion isn't being commanded, which is bit 789, or cam motion also, which is 790. Of course, if it's already jogging in the other direction, I don't want it to try to reverse, so let's check for that too. Go ahead and pause the video and enter this program. Now, back to our first program where we turned on an output based on an input. It would only hold the output as long as we held the input. What if we want to hold the output on all the time? That's where we would use a latch. There are 8 latches available, and they are a reset dominant latch. So if you turn on reset input, it will clear the output even if the input is held on. You could write your own latch this way, but the latch function block obviously makes it faster for entering and is also retained in battery backup on power down. On the second run here, so if 30 is true, 34 will turn on as long as 31 is false. 34 is put in parallel with 30, so it will stay on once it's turned on, but it'll be turned off if 31 ever turns on. This is a reset dominant latch. There isn't a set dominant latch function block, but with the contacts and coils, this is how it would be written on the bottom rung. So if 8 is true, 35 will turn on. 35 is put in parallel with 8, so it'll stay on once it's turned on, even if you release the input. But if the input 8 is off and 11 turns on, then 35 will be turned off. This is a set dominant latch. If you want the AcroPLC program to run on PowerUp, assign this as a pboot like the Acro Basic programs. Go to View, Code Editor. This converts the graphic ladder logic to text. Line numbers are automatically assigned. Insert pboot as the very first line, so type 5 and then pboot. Download and it will run if you cycle power on the ACR. Type pboot in the terminal window, which will run all the pboot programs, or type reboot, which is the same as cycling power on the ACR. This completes the AcroPLC online training. Key points to remember are that the AcroPLC programs allow simple but limited ladder logic programs for input-output manipulation. AcroPLC runtimes can vary and slows with increased system load. For more complex ladder programming, or for applications requiring a specific scan time for execution, use the newer 9600 PAC series controllers. Thank you for your time.